So this is the continuation of part 4, logistic regression. In part 4 we derive Hessian matrix, that is and this is equal to minus x prime wx where x is equal to x naught curl, x1 curl, xk curl, and order of x is n cross k plus 1 with x naught curl is a vector whose all elements 1. And we use Newton-Raphson method to solve k plus 1 unknowns beta naught to beta k, and this matrix, Hessian matrix of order is k plus 1 cross k plus 1, and the method is, Newton-Raphson method is suppose beta naught is our initial guess, beta naught curl, then the first approximation obtained by from this, and we proceed second approximation using beta 1 and so on, and this process continue till beta L curl approximately equal to beta L minus 1 curl up to desired degree of accuracy. So note that note 1, with some data it is possible that the data is so sparse, that is, most people response 0 or most people response 1, then there is no solution. But if there is a solution, it is unique and the maximum. Note 2, in practice, if there is no solution, your logistic regression package will say something like convergence not reach after 25 iteration. Note 3, if the iteration or iterative approach converges, then the MLE is obtained. When MLE is obtained, say it is V naught hat curl, then it is a consistent estimator, and moreover, from the property of maximum likelihood estimator, we know that beta hat curl asymptotically normal, because beta hat curl of order k plus 1, so it is a k plus 1 dimensional multivariate normal. Beta curl, and the dispersion matrix is nothing but a I inverse beta curl, and I inverse is expectation minus expectation del square L beta curl d beta I del beta j and this is nothing but a x prime wx. We have already seen that in part 4, and then it should be x prime w x whole inverse. Now next part, sample size requirement. For approximate normality of Emily. The sample size needed to get approximately normal estimates using a general logistic regression model depends on the explanatory variables and the underlying probability pi. So the sample size, this should depends on two things. One is number of explanatory variable and another thing is pi I. Thumb rule: for the parameters of a given model to be approximately normal, we would like total sample size that is n divided by number of parameters in the model, and it should be approximately 50. For example, suppose we have one explanatory variable then parameters are beta naught, beta 1. So number of parameters should be 2. Therefore n approximately equal to 15 into 2, that is 30. So for when we use one explanatory variable, then we need minimum 30 observations. %95 confidence interval of beta I. This is the beta is corresponding ith explanatory variable. Recall the dispersion matrix x prime w x inverse. We denote it by capital D. Now suppose using iteration you get Emily of beta curl is beta hat curl. Using beta hat curl you estimate pi 1 hat, pi 2 hat, pi n hat. Now using this you compute W hat, and using this W hat you compute this portion and you denote this by D hat. Since we include beta naught, so the variance of estimated variance of beta I hat is di plus 1 I plus 1. di plus 1 I plus 1 is I plus 1th diagonal element of D hat. Therefore 95% confidence interval of beta I is approximately beta I hat plus minus z 0.05 root over d I plus 1 I plus 1. This is a 5% upper 5% percentile of standard normal distribution, and it is approximately 1.96. So this confidence interval is beta I hat plus minus 1.96 root over d I plus 1 I plus 1. Suppose for logistic regression model, a test of interest is whether ith explanatory variable affects the probability of success. So, or equivalently, whether probability of success is independent of ith explanatory variable, and this, so therefore answering this question, our null hypothesis H naught equal to beta I equal to 0. First we use wall test. So this is our hypothesis, beta I equal to 0. And what statistics is Z equal to beta I hat root over d I plus 1 I plus 1, where di hat, where d hat I plus 1 I plus 1 is I plus 1th diagonal element of d hat, which is x prime w hat x whole inverse, and this is follow normal 0 1 in large sample, large samples under H naught. We reject H naught if mod Z greater than 1.96. We reject H naught if we consider 5% level of significance, then this should be greater than 1.96, otherwise accept it. Or you compute p value, that is equal to 2 into probability capital Z greater than observed value of Z under H naught. So this is nothing but a 2 into 1 minus capital phi observed Z. Capital phi is a CDF of standard normal distribution. If p value less than your level of significance, here I consider 5% level of significance, so if p value is less than 0.05, then we reject H naught, otherwise accept it. Next, the likelihood ratio test, then the likelihood ratio statistic, I denote it by delta capital G square 2 into log L beta curl hat given alternative hypothesis HA, where alternative hypothesis here is beta I not equal to 0 minus log beta curl hat beta curl tilde given H naught. This tilde is a MLE of beta curl under H naught, and beta curl hat is a MLE of beta curl under H naught union of HA, or rather it is simply MLE of beta curl. So this is equal to 2 into sum over j from 1 to n yi log pi I hat by pi I tilde plus 1 minus yi log 1 minus pi I hat 1 minus pi I tilde follow chi square with 1 degrees of freedom, where pi I hat is the estimate under the alternative and pi I tilde is the estimate under null. So here we can also compute p-value or critical region approach, that is, first you compute this and the p-value is probability delta G square observed value given delta G square follow chi square with 1 degrees of freedom, and if this p-value is less than your level of significance, then we reject null hypothesis, otherwise accept it, or you can compute the critical value, and then if this value greater than critical value, then we reject, otherwise accept it. Next we consider score test. And the score test statistic is sum over I from 1 to n xij yi pi tilde whole square by variance of I from 1 to n xij yi pi tilde, this is follow chi square with 1 degrees of freedom. Again, we compute p-value or critical value, and on the basis of p-value or critical value, we can make a conclusion. Note that in general logistic regression, this score statistic does not have the simple form, because we have to iterate to get the estimates of beta under null, and thus to get pi tilde. I again repeat this. In general logistic regression, this statistics, that is score test statistic, does not have the simple form, because we have to iterate to get estimate of beta under null, and thus to get pi tilde. So please stay with us. We will continue logistic regression in our next class. Thank you.